Hello, it's me Samiksha, one of the CCNA CCNP routing and switching trainer of Network Alliance, Damak. Today I'm going to discuss about one of the IGP protocols, that is ospf. Normally in our internal network, that is interior network, we prefer to use the ospf. Let us go and find out how it runs. And today we are just going to demonstrate one of the simple lab and going to learn about some of the feature of the ospf. ospf is known as a open source path first. It's an open standard protocol. Open standard in the sense that all the vendors, all the vendor of router can access to this protocol, or they can use this protocol. So it is not a any of the proprietary protocol like EIGRP. So you can use it under any of the vendor. So that's why it is open standard protocol. Another is that like RIP uses like UDP to establish a session. But here on the ospf, there is no any such a TCP or UDP process that ospf follow, or that will have the ospf to form the sessions. So normally ospf runs over the runs with the IP datagram. So it uses the protocol number 89. It doesn't use any of the TCP or the UDP connect UDP sessions. So another thing is that like ospf also does support the multicast. Yeah, it doesn't support the like broadcast. It uses the multicast to form its neighbor, to update its neighbor, and other different updates. So for that, it uses the 224.0.0.5 and 224.0.0.6. In ospf has the different network types. So here it uses especially for the broadcast network type, it uses the 224.0.0.6 as a multicast process, and especially for the non-broadcast network types, it uses the 224.0.0.5. So let us go further. Like ospf is usually it uses the classful addresses as well as the classless addresses, so no problem for that. And another thing is that it also go for link state protocol. Link state protocol. Why it is known as a link state protocol, or it depends upon the link state algorithm. So here one of the major advantages of the ospf is that it uses the cost, link cost, to select the best route. And another thing is that link state protocol usually is one of the major feature. Why? In the sense that it gives all the link state advertisements, which is known as a LSA. How the links are being advertised, and inside the ospf, it gives the complete information to each of the router that is running the ospf. So that's why it is known as a link state protocol. In further classes, we will go deeply regarding the LSA, link state advertisements, and all the thing. But right now, the thing is that it gives the complete information regarding how the links or how the routes are being advertised, in ospf. So that's why it is known as a link state protocol. Another thing is that ospf supports the autonomous system numbers, AS number system from the 1 to 65,530, which is also known as a ospf process ID. So it is a locally significant. And another thing is that the major role in ospf is that it has the areas also. There come the concept of the area also. Usually we call the AS number as a single domain, or it depends particular networks on or it combines the different networks in a single domain. But here inside the particular process ID or the AS number, there are the areas also. Normally area is a 4 byte, but still we can go for the 0 to 65,535. It's also known as a 32-bit informant, but although we go for the 0 to 65,530. These are the areas. And areas is normally the subdomain. We can call it as a subdomain. Okay, if we call the process ID or the AS number as a single domain, then inside that domain we can create the multiple others domain known as the area. So because of the area, like in a particular area, okay, the router in a particular area, okay, like will have a same type of routing entries, okay, same types of database. So it will helpful for each of the router to know the complete information regarding that area. So that's why also it is the more advanced than that of the other ICP protocols. So here what you know is that we call about the area 2. So let me go over here. We have the let me just say, okay, here I have the certain network, okay, R1, R2, and I can call it a R3, okay, R2 and R3. So here these particular routers may be on the different networks, maybe on the different area, okay, they may be assigning the different networks, and they may be on the different area too, R4 and R5. Let me suppose these all are running on a ospf process ID 1. Okay, you can put any of the process ID, you have the options over here, and it is locally significant though, so you can so I'm planning to use the AS number 1. So inside that process ID we are going to create the different areas. So for that case, up to R2 to R3, okay, R1 to R3, I'm going to use inside this, okay, like this, I'm going to use area 0. Okay, I'm going to create one of the domain, subdomain, that is area 0. And here I'm going to use area 1, and here I'm going to use the area 2, R3 and R4. Usually one more thing that this ICP protocols works with the router to router neighborship. So never forget that we have to use the same prefix on this particular link. Okay, so we cannot use the R2 singly on a particular area and R3 R1 different area. Okay, they will not form a neighborship because they go for the dynamic neighborship, and also I said that they must have the same, they must should be a particular link should be light on a same prefix. That was the requirement. So here why we are using the area 0 in the middle is that area 0 is the only one area which is known as a backbone area. Okay, why backbone? Because if we don't make the any configuration, or if we don't create the area 0, okay, then what will happen is that this different area is never going to make a communication. That means, let me suppose here is the another router though, okay, there is R6 though, and I'm planning to make a separate area on this network, that is area 10. Then this particular R5 router will never gonna exchange the route between the area 10 and area 1, between the different area, okay, even though they belong to the same process ID, they are not going to exchange the route. That's why we always have to create area 0, and because this is the backbone area, so with the backbone area all the other areas is going to exchange the route. So that's why we require the backbone area. And although it will be easy for the administration as well. Why? Because the area 0 routers will know the complete information regarding the other routes. Okay, so I already said that each of the router is gonna have the complete information, complete database regarding where these routers are working, regarding the all the area routers. Okay, so even though if area 1 has 100 router, then each of the 100 router is going to create the same database regarding that area. Okay, similarly on the area 2, if there is a 50 routers, then all the routers is going to have the same database regarding that area. So that's why it is known as a linked state protocol. So it is easy to administrate as well. So here are the some of the router functions as well. Normally if any of the router, okay, if any of the router that is running a single area only, just like R2 is running on area 0 only, okay, its complete networks belong to the area 0 only, then this router is known as a intra router. Okay, intra router. Intra means within area router, okay, intra router within that area. And R3 is known as a ABR router, okay, ABR in the sense that it is a area border router, okay, it is a area border router. Area border router in the sense that because R3 had the information regarding the area 2 and area 0. So that's why it is known as a area border router. So similarly, R1 is also noted as a ABR router, area border router. Another thing is that if any of the router is attached with the different autonomous system, okay, let me suppose R4, through the R4 there is another network which is running the EIGRP, okay, and whenever the EIGRP routes is been inserted to the ospf network through R4 by redistribution, then R4 will be noted as a ASPR router, okay, ASBR router. ASPR in the sense that it is running the two autonomous, okay, that means it is redistributing the route towards the OSPF. That means it is running the OSPF as well as the other type of protocol as well. So it is known as a ASPR router. Or if any of the router inject the route from the non-OSPF, okay, non-OSPF in the sense that it may be running the any of the protocol or any of the method of routing, then it is known as a ASPR router. So this is how all the routers is being noted. Okay, so R1 will know, okay, the OSPF runs in such a way, and it is, I already said that it is a linked state protocol. So R1 will know which router is AVR, which router is ASPR. Okay, it holds all the information regarding its area as well as it holds the information regarding from where the route are coming, okay, from either it is coming from the ASPR router, either it is coming from the AVR router. So all the information will be held by each of the routers, so it will be easy to be noted. Okay, it is easy to know the link advertisements. So this is how the OSPF is gonna form its area. So let us go and have some configuration over here in our topology, and I designed the topology in such a way that here having the multiple areas, area 0 is over here, and where running the OSPF is a process ID 1, and here is area 1, and here is area 2. For the very first time, let me assign the IP address and we will proceed on assigning the OSPF. So interface F0/0 IP address 102.1.12.1. I just assign the IP on this one. Let me check it out on the R2 and R3 and R4. Here also I have planned to use the one of the loopback. It's a 24-bit. Yes, I complete it. Okay. So let me go on the R3. Here it has a two interface, physical interface, and one is loopback. And S0/1 I have planned to use the 22.1.34.1. Okay, it's a 30-bit. Okay. And one of them as a loopback. I can have a look over here. So IP interface brief. Yes, you can see that all of the IP has been assigned according to our topology. So the last router left is R4. Let me assign the IP to it also. complete assigning all the IP address, you can check whether the link will be able to make the communication or not. If there is any problem, then. And another thing is that you can also check it out the like IP table, whether you did the proper connection or not. Okay, so you can have a look. I did the proper connection, and I think all the interfaces, okay, all the particular links, all the respective links will able to make the communications. Now we are going to plan to run the ospf, and here you can run the ospf in two of the ways. Okay, I will write the syntax first. That is, what will happen is that, like normally, on one of the thing is that router ospf, and you can give the any of the process id, or I'll just write the AS number. Okay, and second step is that router ID. Okay, router ID means the local identification. Okay, local identification or the neighbor identification or the identification of the OSPF running out running router. Okay, so here the OSPF the router ID can be assigned like can be manipulated in the two of the ways. Okay, one is by giving the static router ID, static router ID in the sense that you can assign the router ID manually, and another in the sense of automatic. Okay, automatic means if you don't assign the static like router ID, then it will go for the automatic election and find out the one. And router ID is in the format of the IPv4 address. Okay, IPv4 address in sense that it will gonna have the four of the sections and separated by the dotted one, just like the IPv4 address. Okay, it is just a format for the router ID. Another is that if you don't assign the static router ID, okay, static router ID means you can assign the any of the addresses that will be on the format of IPv4. If you don't do that, then what will happen is that the particular router will go for the automatic elections, and in that election, it will look for first. Okay, first it will look for the loop back. Loop back means loop back address. Okay, loop back address. If you have assigned the loop back, then it will elect the highest loop back as its router ID. Okay, and if you haven't assigned any of the loop back, then it will look on the physical interface address. Okay, whatever address you have assigned on the physical address, and that in among the physical address also, it is going to select the highest. Okay, highest will be its picked up as a automatic router ID. It is preferred to give the static router ID. Why? Because sometimes if you remove the some of the physical interface, if you remove the some of the loopback interface, then it is like particular neighbor is gonna be reset. So it is better to give the static router ID. But although you can lift for the automatic selection as well. So let me go over here. We're going to do the both. On the very first router, I'm going to enable the OSPF area 1, and the second is that, okay, router ID, you can give the any of the thing. Okay, so after this, we are going to advertise the network, whatever network is there, that is, you will give the respective network. Okay, and then we are going to have the respective wildcard marks, and then we are going to say area, and then we are going to mention the particular area ID. This is how we are going to configure the OSPF. Okay, if you don't know about the wildcard marks, then wildcard marks is a just like a value. Okay, just like a subnet marks. Here we are going to subtract the, okay, we are going to subtract the assigned subnet marks in the total subnet marks. Okay, in the total subnet marks means in the total 32-bit marks, that is a 255, 255, 255 to 255, and we are going to subtract the assigned. Assigned means, let me suppose I have assigned the 30-bit marks, subnet marks, then the value that you will get over here, okay, whatever you will get, 255 minus 255, 0, 0, 0 dot 255 minus 252 is a 3. So this is your wildcard marks. And assigning or giving the certain wildcard marks will notate that, okay, particular network is belong to only this much of addresses, so it will be easy also. Okay, so another thing is that here is no any method like the no auto summary or automatic summarization, nothing. Okay, because you have already mentioned the related wildcard marks. So it's, I already said that it support the both of them. It support the classful addresses as well as the classless addresses. So no problem. So let us go and assign. Before that, again, okay, another method is also there, or same process. router ospf, and you are going to have a particular AS number, okay, and we are going to give the router ID. What is the router ID you want to give? Then another thing is that you can also enable the particular okay, interface. Let me write interface number, and then IP ospf AS process ID and area. And so this is how you are going to enable OSPF in the two of the ways. First, by advertising the network, and second, you can also configure the OSPF inside a particular interfaces. But be sure that you have assigned the IP address already on that interface. Otherwise, it is not going to enable. Okay, so it depends upon your requirement how you are going to advertise the network, as well as however you are going to assign the. You can do the both of them, no problem for that. If you want a particular range to be advertised, okay, if you want a particular range to be advertised, then you can prefer to the network, okay, network by using the network commands. And if you just want to advertise a particular link like that on, then you can prefer for the interfaces. You can do the both. So let me go and check it out, the both of the things. Okay, here on this network I'm going to use the network command, and from here I'm going to use the interfaces, so that we can include the both of the lab. So here on the R1, whatever I'm going to do is that configure router OSPF, how much process ID you can give, 1,265,525. That is a AS number. Okay, same thing, AS number and the process ID. Normally we call the process ID in our OSPF. So here we're just planning to use the one, so I just give. Second is a router ID. Router ID is in the format of the IPv4. So I just want to assign the anything like 1 to 1 to 0, 1 to 0 to 0 to 1. That's it. So here after this, I just want to advertise the OSPF in network by using the network command. So network, I want to advertise this loopback that has a network ID 11.210.0, and WCAG max, it's a 24-bit. Okay, so 24-bit means if you subtract on it to the like 32-bit, then we are going to have the 0.0.0.255 and area, and we are going to have the area. I already said that area also can be written on the IP format also, and can be written in a range also. And I also have said that it is a 4-byte. Okay, 4-byte means normally if it is of before, and the first time it used to be 2 to the power like only up to 16. Okay, that is only up to what you can call 16-bit is 16-bit is a, it noted at a 2-byte. Okay, 2-byte, but now it is in the like how much 32-bit. Okay, that is a IP address format. So in this form you are going to say it as a 16/32-bit as a 4-byte. Okay, so it is also known as OSPF area ID is also known as a 4-byte. So you can use the any of them. I just want to use the area one on this for this loopback, so I just run the. Another, my plan is to assign the 102.1.12.0, and it's of 30 bits, so it is going to have this much of address and going to be advertised in the area one. So this thing will be happened. Okay, so no need to do the no auto summary. It's not recommended. Go to the R2. Similar on the R2 also, router OSPF1. Okay, router ID. Let us see which like router ID it will pick. Okay, it should pick the loopback because we are not going to assign the. So let us check it out. I just want to say router OSPF1, and I just want to 102.1.12.0. Its WCAG max is this one. Sorry, and its area is how much? 1. Yes. Another is also there. Yes, the membership came out, but on the another side, we are going to assign it through the in. So here, the OSPF membership has been opt, and they would exchange the route, and here are the some of the like step they're gonna follow. Okay, they're gonna follow like these all the steps is over there. By default, whenever you haven't configured the OSPF, or whenever you got on the very first time when you initiate the OSPF process, then it is on the downlink. Okay, so after that That what will happen is that one of the router will initiate, okay, on the very first time they will initiate the process on the initial state, okay, saying that like R1 is sending a one of the message, a hello message to the, not directly to the R2, okay, it will send the message to 224.0.0.0.5 if it is a serial link, okay, then other point-to-point link, other non-broadcast link. Then so in this case it is going to send this to this multicast address. So this multicast address is for the OSPF, so it is going to help to send the packet to the next node if it is running the OSPF. If not, then the particular packet will drop. So R1 is going to send the hello, okay, I'm one, who is on the link, or like that one, okay. So if R2 received that packet, then already it knew that, okay, it is sending the packet from the R1, okay. So here you can see that router ID is playing a part. So R2 can send the packet, okay, yes, I see your packet, and it will going to reply back, okay, on the two-way state. First initial state, one of the router will initiate the packet, and on the second it go to the two-way state, and the packet will be reply back. And again, if R1 is the get the R2 reply, then it is to be confirmed, okay, to be confirmed. R1 again going to say that, okay, I also received a packet, and so on, okay, to the R2. And there here it goes with the unicast, okay. Unicast means they are going to communicate between the direct links, not to the multicast address. So after this here comes one of the stages called the DR election if needed, okay. DR and BDR is a concept, okay, concept we can discuss about it later. In a concept, in a broadcast network, okay, they select the one of the router as a DR, designated router, through which all the manipulation or all the route forwarding will take place. And that means all the other router will make a neighborship to whom, and it will like in the broadcast network, usually what will happen is that, like, let me suppose over here, okay, this is a switch, and here are the some of the router. Then what will happen is that they are going to form, obviously in the broadcast network, they are going to form the all the neighbors, okay, mesh neighborship, okay. They will yeah, in the mesh neighborship, the like feature, one of the best thing about the mesh neighborship is that they can converge faster. But if a certain routes fail, then the query message will make mass domain. So in order to stop that, the DR-BDR concept is there. So they will elect the one of the router as a DR, okay, and all of them is gonna make the neighborship with it. And BDR in the sense that backup designated router, okay. If DR fails, then BDR will be a DR, and other are the DR other. So or other remaining will be the DR other, okay. So here all other router will make a neighborship with the DR, and DR is going to have the neighborship with all the one, and DR other and DR other is never going to have the fully neighborship. So this helps to break the mass to broadcast in a broadcast domain or in a broadcast link, okay. So whenever you are using the broadcast links like the fast ethernet links, then they're going to form the DR-BDR election. And normally on the serial link or the WAN link, there is no any such elections, okay. So let me go over here. So if and that was the case, if that type of link is there, then they will go through this state, okay, DR and BDR state. Otherwise this state will be skipped. After this, I already said that in OSPF, okay, in OSPF they have to share all the information regarding how the link, regarding the link state advertisements, okay. So for that case, OSPF has your 3 tables, okay, just like the AIGRP used to have the 3 tables, and the same type OSPF is also going to have the 3 type of table. One is the neighbor table, okay. Neighbor means the containing the information regarding the neighbor, okay, neighbor table. Another is all about the database, okay, database or the link state, okay, link state table or the link state advertisement table, okay, we can call it as a database. And finally they are going to have the routing table. So all 3 types of table is there, and in the database table they are going to have all the LSA information, okay. So so that is the main role of the OSPF2. So in this case, after this, okay, after they receive the packets and they check out, okay, both of the router is running the OSPF, okay. After this, one of the router is going to ask for the database information, okay, just send me the database information, saying that to the R2, and R2 is going to reply it back. And yes, they exchange the database tables. Okay, here you can see that they exchange the database tables and all these things. So okay, between the both of the router. And if on the loading history, what will happen is that if they will acknowledge the all the routes, okay, all the database, how the routes have been advertised and all these things. So if any of the error occur or if any of the route is missing, then what will happen is that both of the router or among one of the router will initiate a packet. Okay, this particular route is missing, or if there is any other route like that on. Okay, so they will request for the route, they will update the route, they will acknowledge the routes. Okay, link state request, link state update, link state acknowledgement. Okay, so they will go for the requesting the route. And if r1 if let me suppose one of the route is missing, so r1 request for that route, r2 will update its route, and r1 will acknowledge the all the routes, and finally it will set the make a proper routing table for the base routes. Okay, so after this, if they go for if they complete the loading state, then finally they are going to converge, that is they are going to make the full state neighborship between the r1 and r2. So this is how they go for the all the layers or all the steps to make a complete neighborship and extend the route and make the neighbor table, database table, and the routing table. So let me go over here. So this is how they elect. And so let me go over here and let me go over here on my topology and configure the list of the configurations. So on the R2, I have already said that ospf can be configured on the both of the ways by advertising the network, also by advertising the interfaces. So here I have already did by on these sessions on the area 1 by advertising the network. So I'm planning, okay, I'm planning to use on the interfaces so that I can include them. So here interface S0/0, it is easy, IP ospf process ID 1 and area, or which area you are planning, that is S0/0 on area 0, so 0. Okay, so on loopback also, and I think it's loopback 0, or I can check it out which area is it, and ospf. Let me check what is the interfaces. Okay, so you can see a message like I want to say look back 1 and I just want to advertise the interface, then it will fully you say that ospf will not operate until and unless IP is configured on it. So you have to design the IP first and then you can enable the ospf. Okay, so it depends upon your requirement as well. So right, completed. So similarly on the R3 too, I want to advertise it on the links, configure terminal, okay, router ospf1, and obviously I have to give the router ID, and I prefer to give the static router ID. Interface S0/0. I'm planning to advertise this interface on the area how much? Area 0. I have the another interface like S0/1 2. Okay, you can see over here on this area. This is area, and here on this interface I'm going to assign the area. So S0/1 area will be 2, process ID is 1. Okay, so interfaces you can advertise the any of the interfaces, like I want to advertise the 13 look back, okay, on area 2. So do right, the neighborship is going up, and you can see it on R4. On R4 same S0/0 and the look back, both of them is going to advertise on the area. Very simple. You don't have to care about the network while advertising through the interfaces. That was the one of the advantage. Okay, so router ID I want to give the manually 0.0.0.4, and interface 0/0. ospf process ID is 1 and area is 2. And I have the look back though, so I want to advertise it to the. So yes, I configure almost all the ospf process. I want to check it out. Okay, do so. I want to end in means, because normally we run the so command in the privilege mode. So I came back. So IP ospf. Okay, I just want to show the ospf interface brief. That means I want to be confirm which of the interface has been. So look back 0 is assigning the process ID 1, area with the 2, and IP address is here, and cost is 1. Cost means normally ospf works with the cost, and it normally calculate on the basis of bandwidth. Okay, and loop, it is a loop back state. Okay, and neighborship, no neighborship with the loop backs. But with the interface, that is S0/0, it has one of the neighbor with the R3. So it is saying that it has one neighbor. Let me check it out the neighbor. So IP ospf neighbor. Okay, this is the command to check it out the neighborship. So neighbor ID means not the interface IP. Okay, it is a router ID of your neighbor. That is a of R3. If you remember on the R3, we have configured the router ID as 3.0.0.3. So it is the neighbor router ID. And priority 0 means if there is a certain priority value, then they will go for the elections. Okay, elections in the sense they are going to election for the DRPTR. But usually on the this point-to-point links, okay, on the WIN links, there is no any election regarding the DR and BTR. So their priority is 0. So here you can see there is no any DR and BTR. Just the state is full. And date time means hold on time, and address is to which neighbor, that is 102.134.1. Okay, and to which interface, exit interface S0/0. Let me check it out the route also. Okay, so IP route. So here you can see that 13 the route is when applies, it is noted as a O. O means intra-area routes. Okay, intra-area means if any of the route, okay, let me suppose this 13 route 13.1.10.0 24 bit is been applies to the area 2, and R4 also know about the area 2. Yes, this area is intra-area for R4. Intra-area in the sense that within the same area. So for the routes which is on the same area, it is going to have going to share the code O only. O means intra-area routes. If any of the routes are coming from the inter area means from the different area, then it is going to set the code OIA. That means ospf route from the inter area. Okay, it is a inter area. Inter area means from the different area. So you can have a look like this 102.1.12.0 network. This network is coming to the area 2 from the different area. So that's the OIN, and 12 is also coming from the different area. Okay, just the 13 is within the same area. OSPF has the administrative distance of 110, and this value is the cost. Okay, this is a cost, and it is coming from where it is a next hop IP or the gateway. You can call it as a gateway, uptime and exit interface. Okay, from where it is receiving the interface, or from where it will be exit to receive to that network, and that is S0/0. So this is how they're gonna set the entries. Okay, so let me check it out on the R1, R2. Okay, I just wanna check it out on the R2. IP protocols. Okay, I want to check it out which protocol is running. I know there is ospf is running, and its router ID is 12.1.10.1. If you remember, okay, if you remember that, then we haven't configured any of the router ID, okay, manually. So what happened? So what happened is that this router ID, this router go for the default election, okay, or go for the automatic election. In the automatic election, we have already said that if you don't assign the router ID manually, then they are going for the automatic election. And in the automatic election, first they go for the loopback addresses, and there is only one loopback assigned, that is 12.1.10.1. So they just pick up that address as a router ID. And you can have a look routing for network. It is advertised on the area 1, and 2 of the interfaces on the loopback to area 0. Okay, you have advertised loopback 0 and S0/0 on the area 0, and gateway are 2 of the gateway, distance is 110. So this is the information of your IP ospf interface. I just want to show the S0/0. Okay. So you can see router ID is this one, network type point to point, and cost for this link is 64. Okay, so here all the things has been said. We're gonna have a look over here too. Okay, this is a ospf. So IP ospf interfaces. So if you just say the interfaces, then there you are going to have the complete information regarding all the interfaces. Okay, so IP ospf. So here you are going to have the ospf information. Okay, ospf 1 route ID, what route ID you are running, okay. And also I have said that area 0 is a border router. So this router is running the area 0. You can check it out, okay. So just want to see the brief interface. So it is also running the OSPF area 0. So it is saying that this is a what it is a border router, okay, because it is running the two of the areas, area 0 and area 1. So it is saying that it is a area border router, okay, because it is running the two of the area. So let me check it out on the another also, like on the okay, we see on the R2, and I want to check it out for the R4, okay. So IP OSPF. So right now, okay, so right now it is not like it is just running a single area. It's just running a single area, not the multiple areas. So you can check it out like this one also. So this is how we configure the OSPF, and you see all the routes, and okay, this is a simple demonstration for the OSPF.